Look at section 2-4, and what we're going to be looking at is writing proofs as they pertain to algebra. Now, almost everything we're going to list in these proofs are things that should be very, very familiar to you. You just have not put a name to this process yet, and that's why it'll look all new to you. So what we're going to do is take a look at those algebraic properties that you've used so far in algebra and how they are going to be used in geometry. So the first one is this property of addition. And that's when you have an equation, A is equal to B, then you add C to both sides, and the equation is left unchanged. So an example of this might be that you have x plus 3 equals 5. If I add 3 to both sides, x plus 3 equals 5 plus 3, the solution is still 2. It hasn't changed. I can add the same value to both sides, and I haven't changed the equation. The same is true for the subtraction property, just I would be using subtraction. So if A is equal to B, then I subtract C from both sides. The equation solution is unchanged, or still the same. Next, we're going to look at multiplication. So the multiplication property says if A is equal to B, and I multiply both sides by C, then the solution is unchanged. So let's look at this as something like if I have 2x is equal to 10, then if I multiply both sides by 1/2, I get x is equal to 5. So I've multiplied by the same number, and it leaves the solution unchanged, just as it would be here, x is equal to 5. Division property looks very similar to the multiplication property. They are opposites of each other. So if you divide both sides, for example, if I had that same example, 2x equals 10, we know the answer is x equals 5. If I divide both sides by the same number, 2, I get x is equal to 5. So the solution doesn't change when I do the same operation to each side. The reflexive property will make a lot more sense when we actually encounter that, and that just says that A is equal to A. The symmetric property says that if A is equal to B, B is equal to A. So if I reverse those, they're still equal. Transitive property says if A is equal to B and B is equal to C, then A is equal to C. You can take that middle part out. Sort of looks like the law of syllogism, only in algebra we're going to call it the transitive property. Substitution property, if A is equal to B, B can replace A in any expression. Sorry, that any should be on the other side. That's not there. It should be here, in any expression. So those are the properties of equality. We'll use those a lot in the proofs coming up tomorrow and then in the proofs in the next several chapters. So let's take a look at our first proof and how we can actually think about this proof. I am given that the measure of AOC, this whole angle, is 139 degrees. And what I want to prove when I'm finished is that x equals 43. So this is the information I'm given. This is what I want to prove. And if you look at this picture, you have hopefully recognized angle addition. Angle addition. So under, let's go ahead and start making this look like the proof we did in class today. Statement and reason. If you notice today when we did the proofs, we always started with what we were given. So we have the measure of angle AOC equals 139, and that is given. Okay? So we know that that is true. If we look at the picture we're given, we actually know that the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. And that is angle addition. If you remember correctly, that is angle addition. I'm going to try to make this look a little neater. Move our reasons over. Okay, so by looking at that as angle addition, I can make some sense of that. I've justified what I have here with the picture. Now I know that the measure of angle AOB is x. The measure of angle BOC is 2x plus 10. And the measure of angle AOC is 139. Now this particular property, I'm not sure we have talked about yet. It is called the substitution property. Of equality. I'm going to back up and see if I missed that on the last page. Oh, there's the distributive property. Substitution property was the last one. I didn't miss it, but I did miss the distributive property. So we'll come back to that if we need to. So from the last page, the substitution property of equality. We will use this one a lot. You'll see this substitution property almost every proof. So the next step, now just think about the algebra. Just think about the algebra you would use to solve this equation. The first thing you should do is simplify by combining like terms. So this becomes 3x plus 10 equals 139. And that is, you can say combine like terms or you can say simplify. So you've simplified that equation by combining like terms. The next thing you would do algebraically, as you're looking at this, you would subtract 10 from both sides. So instead of writing down that minus 10, you're just going to go to what the result would be. 3x is equal to 129. And that is the subtraction property of equality. Subtraction property of equality. Finally, number 6, I'm going to then divide both sides by 3, and I'll get that x is equal to 43. And if you look at that algebraically, the property that you used is the division property of equality. The division property of equality. And that is one of our first proofs. Angle addition from chapter 1. And then this particular group right here, this is all algebra you already know how to do. All we're doing is putting some definition or justification to why you've done what you've done. That's all a proof is. So the algebra should look very familiar. The reasons are the part that looks new. Let's take a look at another proof. So again, I'm going to start with my statement and my reasons, so my justifications. And I start, the first thing is with my given. What am I given? Ray LM bisects angle KLN. And that is given. And as soon as you see that word bisects, I know you grabbed your pen and you marked the picture that they are congruent. So now when you think about the idea that ray LM bisects KLN, you know you get two congruent angles. And you can actually, that's going to be your next statement. That comes from the fact that ray LM bisects angle KLN. Now you know that angle KLM is congruent to angle NLM by the definition of an angle bisector. Okay, by the definition of an angle bisector, you know they are congruent. Number 3, now you know that the measure of angle KLM is equal to the measure of angle NLM, and you know that by the definition of congruence. The definition of congruence says that if two angles are congruent, then they have the same measure. If two segments are congruent, then they have the same measure. Now, we can go back to the picture and look at the measure of angle KLM. That is 2x plus 40, and that is equal to the measure of angle NLM, which is 4x. And again, by the substitution property of equality. And we're just going to put a little equal sign there to abbreviate. Now we're to the algebra part. We're at a place, hopefully, that looks very familiar. And let's see if I can move this down. So now we're going to take a look at what we would do with the algebra. Well, I have 2x plus 40 equals 4x. I'm solving for x, so I'm going to subtract the 2x from both sides. So 40 is equal to 2x. What did I use? I used the subtraction property of equality. The subtraction property of equality. Now I'm solving for x again. So I'm going to divide by 2. So 20 is equal to x. And I have used the division property of equality. And I have the last line of your proof should be whatever you were trying to prove. So here, the last line of my proof is what I was asked to prove here. The first line of my proof should be what I'm given. And just like the proofs we did in class, everything in between has to be justified every step so that we can see how we made the move from one thing to the next. Okay, one more. Hopefully this will look familiar to you as well. We'll look at, this is what we're given. This is what I'm trying to prove. I have a picture to use. So when I look at this picture, I'm going to see if I have room here. I have statement. And I have the reason. I have that AC is equal to 21. So AC is that length of those two segments. That is given. So I have to look at how can I get from the whole length is 21 to understanding what y is, and that is understanding segment addition in this case. So I know that AB plus BC equals AC, and that is segment addition. Segment addition. So then I know that AB is 2y, BC is 3y minus 9, and AC is 21. There it is again. Substitution property of equality. And then again, I'm going to simplify this by combining like terms. So I have 5y minus 9 equals 21. Simplify. Then number 5, I'm going to add 9 to both sides. So I have 5y is equal to 30. And that is the addition property of equality. Then I will divide both sides by 5, and I will get y is equal to 6. And that is the division property of equality. And that ends that proof. So again, I ended with what I was trying to prove. So I ended with what I was trying to prove, y is equal to 6, and I've justified everything from my given down to the end of that proof. We have a couple of more properties we're going to look at, and then tomorrow in class we're going to work on some proofs. So let's take a look at these last few properties. The reflexive property says AB is congruent to AB and angle A is congruent to angle A. These properties will make a lot more sense when we actually use them in a proof. The symmetric property says if AB is congruent to CD, CD is congruent to AB. And likewise with an angle. The transitive property, again, looks very much like syllogism. If AB is congruent to CD, CD is congruent to EF, then AB is congruent to EF, and that's the transitive property. So when we look at these, identify these properties, I have angle K is congruent to angle K. That is the reflexive property of congruence. And you can just use the congruent symbol. 2x minus 8 equals 10, then 2x equals 18. That would be the addition property of equality. If RS, segment RS is congruent to segment TW, and segment TW is congruent to segment PQ, then segment RS is congruent to segment PQ, and that is the transitive property of congruence. Number 4, if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A, and that is the symmetric property of equality. And we'll talk more about those tomorrow. And we will start to actually look at these proofs together in class. Thank you for watching. I'll see you tomorrow. Have a nice evening.